Welcome to your next linear equations tutor training video. This video is actually about inequalities instead of equations. First, let's review the symbols. We have less than, we also have less than or equal to, greater than or equal to. Whether you remember this as alligators or Pac-Man, it's important that you can help students know which one is which. This is how I remember. The less than symbol, to me, looks like a down, beginning the word less. And the greater than symbol, I can make as part of my capital G for greater. That's how I remember. Let's look at when there are variables involved. So when you have some number x is less than 4, that is not just one number. It is now a set of numbers, all of the numbers that are less than 4. So it includes 0, includes negative 32, negative 3017, all the numbers that are less than 4. When you have some number x, let's say, is greater than or equal to negative 6, that can be all the numbers bigger than negative 6 and negative 6 itself. There are different ways to annotate these inequalities. You can write them as is, but you can also show them on a number line and use integral notation. Let's look at the number line first. So we're going to draw an arrow and point it towards the direction of all the numbers that are included in this set. So if we're looking at 4 as our starting point, it's going to be all the numbers to the left of 4. You'll see some students who draw the arrow on the number line. It can also be above it. And for negative 6, we're going to, let's see, I have 0 for my marker here, negative 6. And I'm going to point my direction towards all the values that are to the right of negative 6 or more than. We also want to include whether we are including that number or not. So at x is less than 4, at 4, I'm going to leave an open circle. It's got a hole there to show that we are not including it. So anything that has just less than or just greater than, you're going to use an open circle to represent that you're not including that number. For this one, x is greater than or equal to negative 6, we're going to go with negative 6, and instead of having an open circle, we're going to fill it in to show that we are including negative 6 because of the or equal to in our statement. We are including that. I also want to point out that sometimes you'll see inequalities written the other way with the variable on the right. So x is less than 4, that means the same as 4 is greater than x. Negative 6. X is greater than or equal to negative 6 is the same as negative 6 being less than or equal to x. So as long as you flip everything around, it still is saying the same thing. Integral notation uses parentheses and brackets and commas to represent a whole interval, not just a variable and a number. So this is saying the number x is somewhere along this interval. We're going to start at the smallest it could possibly be. So we're just going to say negative infinity because we don't know the smallest number. And it's going to go all the way until 4, and then it's going to stop. So in between, you're going to put a comma to represent the interval, and then we're going to put parentheses on the outside. For our other inequality here, we're going to start at the smallest it could be, which is negative 6. And we're going to go all the way, put our comma for the interval, to positive infinity, and put parentheses. However, when you include it, kind of like having a closed circle up here, you're going to put, instead of parentheses, a square bracket. So a square bracket for those, and parentheses for these. And just a reminder, you never put a bracket on infinity because sadly, we are mortal. We cannot hide the collab yet. And so infinity cannot be included in our interval. We're just going to have a parentheses to show that it's the idea that it gets smaller and smaller and smaller, or bigger and bigger and bigger. All right, now you know how to write it. Let's talk about how to solve it. Surprise! It's the same as solving equations with one small exception that we'll talk about in a minute. So let's go ahead and look at an inequality and follow this process. Let's simplify first by distributing. I have negative 4x. Negative 4 times negative 3 is positive 12, less than or equal to. I've got some like terms I can combine. I don't know how many fractions are decimals, so I'll go ahead and combine these. I have 10 minus 6x combining those. And now I can add or subtract to collect all the variables on one side. Let's go ahead and add 6x. So I have 2x plus 12 less than or equal to 10. Go ahead and subtract 12. And the last step, I'm going to divide to get the x alone. Oops, not -2. Divide by +2. And you get x is less than or equal to -1. If I plug that in, it will give me a true statement. Or if I plug any numbers in that are less than -1. And then if we were going to put on a number line, we have a square bracket or a closed circle. Here's -1, closed circle, everything to the left. In interval notation, it would be -infinity all the way to -1, include -1. So same exact process that you learned in the last video of solving equations, but now there's an inequality symbol. Let's talk about that exception though. Imagine you have 5 is greater than 2. True statement, very true. If I take that and to solve, kind of like I was doing up here, add things, divide. If I multiply by -3 on both sides, I get -15 is greater than -6. Sadly, that is no longer true, right? -15 degrees is definitely colder than -6. So in order to make it true, to erase that, I have to flip the inequality over. So now it says -15 is less than -6. If I had multiplied or divided by a positive number, that wouldn't be the case, but negatives mess things up. So in your solving, if you divide or multiply by a negative, you must flip the direction of the inequality so that it is still a true statement. So for example, if we have -3x is less than 6, and we're dividing to solve it, we would then flip that over. X is now greater than -2. Those values, if I plug them in, will give me a true statement. Sometimes you need more than one inequality to show a set of numbers. These are called compound inequalities. We're going to talk about two different types, the AND kind of compound and the OR kind of compound inequality. Let's look at first AND. Okay, so here we have two inequalities and the word AND in the middle. Let's talk about what that means. We're going to get some answers for x, and we want to talk about where both criteria are met, where both x minus 5 is less than 5 and -2x is less than -8. So let's go ahead and solve that. Add 5, x is less than 10. Let's keep our AND here. Solve this one. Ooh, a negative. I'm so good at reminding you of that already. Flip the direction of the inequality. X is greater than +4, so divided by -2. So if we look at a number line, there we go. We're going to look at where x is less than 10, just drawing a little arrow, less than 10, and where x is greater than 4. Well, that was a wonky arrow, wasn't it? So obviously, like the number 11 is greater than 4, but it is not less than 10, and so it does not meet both criteria. So where our AND is true is where they overlap here in the middle. Oh, not closed circles. These are open circles. That's where they overlap. So you're going to have a line in between the two circles. Interval notation would look like this. 4 all the way to 10. You always put the lower number first. Oftentimes you'll see AND inequalities written like this, where they just put the expression in between the two inequalities, and it's really saying two inequalities in one, where this expression is both -2 is less than it, so it's greater than -2, right? Think about it the other way around. And it's also less than or equal to 2. So if we're just, before we solve it, to put it on a number line, it'd be between -2 and 2, this expression, somewhere in there, okay? But let's go ahead and solve it. And when you solve these with equations, you know you do it to both sides, but now we have 3 sides. So we gotta make sure we're doing it to all those spots. So let's multiply by 3, get rid of that fraction. Because it was a positive number, I don't have to flip anything around yet. Okay, Keep solving, add 1. So that's negative 5. It's less than negative 2x, less than or equal to 7. Now I am going to divide everything by negative 2. So that's going to flip things around. So I'll have 5 halves, or 2.5. Switch the direction of the inequality. X. Switch the direction of this inequality 2. And 7 halves, or 3.5. Oh, negative 3.5. So we look at this one on the number line. Oh yeah, I can't reach down there. So we'd have start at negative 3.5, the smaller one. Close circle, open circle at 5 halves or 2.5. Open circle. Wrote it too small. There we go. It kind of looks like it's winking now. So that's what an inequality will look like. You're going to have two sides to it. And it'll be wherever the two inequalities overlap. Or inequalities, but not both criteria are to be met. Just one of the criteria has to be met. Here's what I mean. So if we find the value for x that, when you add it to 9, is less than 0, but it doesn't work for the other one, that's okay. Both will work. As long as one of them is met, we're good. So let's go ahead and solve this and I'll show you on a number line what I mean. Solve this one. Don't have to flip either of these. That's nice. So if I look at the number line, oops, I have one. Look at that. I'm at negative 9. I want the numbers that are less than negative 9. That way. Open circle. And negative 3. Open circle again. That way. So the order, if I have a value like negative 10 that works for one of the inequalities but not for the other one, that's okay. It's a take-all. Now these ones, the interval notation will feel a little bit weird, but what you can do is you start again at the lowest, negative infinity, all the way to negative 9. And then you're going to close parentheses. And then for the other one, you're going to go from negative 3 all the way to positive infinity. And what you do is you put a symbol in the middle. It's a U for union, but it means the same as or. So it's the same. This one, or interval, or the other interval. But this is my full answer in interval notation. All right, that's inequalities. Go ahead and look at absolute value.